Midpoint. Somebody tell me what a midpoint is.
Point that separates the line and slide it.
Point that splits the segment into two equal segments.
I said separates, alright.
And perpendicular. What's perpendicular?
Lines that intersect to form right angles.
Lines that intersect to form right angles. Theorem.
Oh, a mathematical statement that is true.
Mathematical statement
That is true. That is
that has to be proven true. Alright, so make sure. Theorem has to be proven. Let's jump down to postulate.
Statement that
Accepted as true. So this one's just true. This one, we have to prove true. Vertical angles.
angles that are congruent that are on opposites.
Alright, if you draw the two lines, they intersect. They're non-adjacent. You have two intersecting lines. They're the non-adjacent angles. The angles that aren't hooked to each other. Congruent. What's congruent?
Same measure.
Same measure. Angle bisector.
Two
I know that one.
a ray that splits two angles to form a congruent angle.
What?
A ray that splits an angle. A ray that splits. Listen, because I'm guaranteeing you're going to see every one of these again on some quiz or test on down the road that's vocab like this. A ray that splits an angle into two congruent angles. Collinear. What's collinear? Two or more points that fall on the same line. Postulate we just did. Supplementary angles. Two angles, that's important, that add up to be 180.
I have a question.
Yep.
On collinear, did you have to put, wait, I don't remember.
I put points
Yeah,
in
did you
lines.
just put two or more, or did you just put two?
Yeah, I'd probably accept two. But no, it's two or more because any 2 points are always going to be on what? A line, no matter where I take them. But if I pick 3 points, then you got to start deciding if they're collinear or not. All right, any 2 points are collinear, but 3, 4, 5 could be collinear. They might not be.
So if you just put 2 points on the same.
Next time I'll probably mark it wrong. Linear pair. What's a linear pair? Two angles that together form a. All right, you should be ready to ask me questions.
I got you.
You have to read the question to me. I don't have a test, so I'm not going to go grab one. So read the question to me. Doesn't need to be any other conversation. There's only, 22 questions on the test? So if somebody reads a question, can you find where it's at? Yeah. Oh, y'all have to, what number's up? So let's just, otherwise, Travis knows. Probably not going to fix them, right? Because I have this back here. All right, Travis.
Well, it says prove the following, and given is, WX equals YZ. Proved is WY equals XZ.
Equals XZ.
Yeah, and then it says proof, and then statement, the understatement is 1.
Yeah, slow down. What's the picture look like?
Yeah, straight on, I forgot there was even a picture there.
A segment maybe?
Yeah.
Close enough?
And there's like 2 dots.
2 dots in the middle?
In the middle, and then 2 on
Yeah,
the
that's
outside.
alright.
So what's this point?
W, X, Y, Z.
Yeah, thank you.
Alright, so we have that. And I know they gave you the steps and stuff, and we'll talk about that here in a minute. But right now they tell us WX equals YZ. So this segment equals that segment. What can you tell me about from here to there and from here to there? They're going to be equal because all I did, oops, sorry, I didn't go out far enough on this one. My fault. Didn't go out far enough. All I did to this first one is I added what segment to it? XY. What did I do to the second one to get this whole thing? Added XY. So I added the same thing to both of them, so the 2 new links should be the same, right? And let's see, the 2 new links, well, looky there, that's what we're trying to prove. What's the first statement they give you? I bet it's this, isn't it?
It's given.
So you knew that was given.
And then the second one, XY equals XY.
XY equals XY.
Reflexive.
How do you know that this segment's equal to itself? Oh, speaking of which, the definition stuff, just to give you a little heads up for the next one that we take, reflexive property is probably going to be on there. What are you going to write?
Equals itself.
Anything equals itself. That's all you got to write for reflexive property. So reflexive property, it's reflexive, an X in there, property, not reflective property. Doesn't have anything to do with your image in a mirror or anything else.
This one, WX plus XY equals XY plus YZ.
WX plus,
XY equals XY plus YZ.
so all they did here, notice you, up here you said this equals this, well that's those two things right there, and they just added what to both of them? XY. So what property did we use?
I put transitive, but it's wrong.
Yeah.
Addition property.
Oh my god.
You just added the same thing to both sides. You added XY to both sides, addition property. 4. I'm going to run out of space, I'm sure here. There's only 5 steps, there's only 5, isn't there?
Yes. This one's WX plus XY.
Watch, because I'm going to write this one up here so I don't run out of space.
WX plus XY.
All we're doing here, WX plus XY
Equals WY.
equals this whole thing, WY.
And then under it is.
And I'm not even going to write out the rest of it. The other one's going the other way. What property is, or I'm sorry, what postulate is that? Segment addition. So you see this plus this equals the whole thing, segment addition. So we know 4 over here, segment addition postulate. It's not a property, it's a postulate. I didn't take all points for that, but it's a postulate. Step 5 is what we're trying to prove, right? All right, so I guess I will go ahead and write this one out. The other one said what? Let's see, we got XY.
XY plus YZ equals.
I'm going to write it a different way. Equals XZ. Well, look at what we have here. What did we know about these two whole things?
They are.
They were equal. Well, they're right here. Well, if those two are equal, what's that tell us about these two?
They're equal.
They have to be equal. What property tells us that?
I have no idea. Is that the.
If we know this is equal to this, then any place we see this, we can stick that in there. It's just substitution property.
See, what I was. What I guess I don't understand why. Is it transitive if like at the end?
If it would have been, if it would have said this equals WY, then WY equals something else, that's the only time it's
That's why I
transitive.
thought it was substitution or transitive, but.
Substitution works. So Travis, if you think that, then anytime you think it's transitive, put substitution. Because,
And no matter if it's transitive, it's taking on your substitution.
yep, because if it's transitive, then it's a form of substitution. But if it's substitution, it doesn't necessarily have to be transitive property. All right? Next question. Give me 1 second here. All right, Brianna,
Number 9.
read it to me.
And then X is a real number, and investor is X.
Sorry, my thing's not written very well. X is a real number, and we're trying to decide whether this is a true statement or not. Negative X less than 0. So we know this is true. They're telling us this, but we're trying to decide whether this is true or false. And if it's false, we got to give a counterexample. So X is a real number. Real numbers, all real numbers are, is every number that you've ever dealt with in your mathematical career. Real numbers. That's all of them that you know. All right, there's other numbers, but you don't know them yet, so we won't deal with them yet. X is all real numbers. Is this a true statement? Is the opposite of X always going to be less than 0? Give me a number. Let's try it and see.
3.
3. So if I put 3 in there, is that less than 0? Yeah. So does that mean it's true because we tried one thing and it worked out? How many things you gotta try to prove something's true?
Unlimited.
All of them.
All of them, yeah.
Unlimited amount, an infinite amount. All we need though to prove that this is false is how many? 1. So we need to come up with a counterexample unless we think it's true.
Negative 3.
-3. Let's try that and see. The opposite of -3 is less than 0. Well, what is the opposite of -3?
Oh,
Is 3 less than 0?
and what about 0?
Is that a counterexample then? Did we prove it was wrong? Yeah. So this is false. And then your counterexample would be x could equal, what Travis just tell us it could equal? -3.
What page is this
I
on?
put
So false, and then you got to give a counterexample. X equals -3. Now, did you have to have -3?
no.
Give me another counterexample. -2, -5. How about 0? Somebody said
Yeah,
0
I put
earlier.
0, but you put x equals question mark.
Right, if you put x equals, then,
So this was supposed to be the other
oh,
one.
you got lucky because I didn't take a point off.
So that was supposed to be the other one?
You should have put this, x equals 0. That would be a counterexample.
Alright.
So, because then you're plugging in 0 for x. Other questions? All right, Ethan.
In the figure, points A, B, and C.
Hold on, give me 1 second. Let me erase this.
7 on it, sorry.
Let me erase this. Say it again.
In the figure, points A, B, and C lie in plane Z. Which of the following postulates can you use to show that A and B are collinear?
So you got this plane, A, B, and C all fall in this plane. All right, I don't even know what the plane looks like. Does it really matter? No. What postulate can we use to prove what?
That A and B are collinear.
How do you know that this point right here and this point fall on the same line?
Because there's only one line.
There's exactly one line through any 2 points in the world.
So
So it's D.
D, is that what it is?
Or A, how we messed up. Well, is it D or A?
I don't know.
It's
Through any 2 points, there is exactly one line. That's the answer.
The test.
Through any 2 points, there's exactly one line. Through any 2 points, there's exactly one line.
I forgot, I had like all these right, but I forgot to tell you.
I think I mentioned that right before the test too, didn't I?
Yeah, I'm sure you did.
To make sure you told whether they were true or false on the inverse, converse, contrapositive.
Yeah, that's how I remember.
I even had people write it right there next to the problem real big. Tell whether true or false. And then guess what they did? They forgot to do it. I'm like, really? All right, Jacob, last one.
Number 12.
Read it to me.
That's figures for right angles. Or right the converse, inverse, and
Oh,
contrapositive.
you want me to do the long one?
Yeah, you have to.
All right, if what?
If a figure is a square, then it has 4 right angles.
If figure is square, and I'm going to shorten this up a whole bunch, then 4 right angles. First thing, if you don't label this as the converse, am I going to know which one it is? And I gave some of you a break and said, all right, I think that one's the converse and this. But if you put them out of order, I have no clue. I just marked them wrong. What's the converse do to a statement?
Switch.
Switches the hypothesis and the conclusion. So what's it going to say?
If it has 4 right angles, then the figure is square.
If figure has 4 right angles,
Then the figure is square.
then it is a square. Is that true or false? Now, when you're looking at this, this is the part that they're telling you. So you know this is fact. You got this shape and it's got what? 4 right angles. So I draw a shape up here and I tell you it's got 4 right angles. Can you tell me with 100% for sureness that it's a square? No. So that means this is false. Inverse. What else could it have been if it wasn't a square?
I rectangle.
Could be a
I
rectangle.
didn't even think about that.
So if, what's the converse do to a statement?
Switch it, stays the same and, negative.
Leaves it in the same order, but negates both parts. So what's it gonna say? Oops, if figure, forgot a word,
It's not.
figure is not a square, pardon my grammar here, because I'm not writing them out completely, then
Does not have
doesn't have
four right.
four right angles. Terrible writing.
Can you say that all real quick? Just-
Yeah, if a figure is not a square, then it doesn't have four right angles. Figure is not a square, then it doesn't have four right angles. Again, we know the figure here is not a square. So I say, all right, I drew a shape on the board. It's not a square. You know this is true for sure.
No.
So that's false, because again, it could be a rectangle. Contrapositive. I'm not even gonna put the contrapositive up here because my writing's getting worse as we go. Contrapositive, let's just say it. What's contrapositive do to a statement?
Switches and negates.
Switches and negates. So what's the contrapositive of this one gonna be?
If it does not have four right angles, then it is not square.
If it doesn't have four right angles, comma, then it is not a square. If it doesn't have four right angles, then it is not a square.
True.
Is that true or false? It's true. If it doesn't have four right angles, so you got this shape. I draw a shape on my hand here. And I tell you, it doesn't have four right angles.
It's a circle.
So it can't.
It can't be a square, can it? So that's got to be a true statement.
Number 14.
What's it say, real quick?
All integers are the numbers, half the number.
All right, so we know this. Real quick, all integers. Now, I'm not even going to write all of it out. Let's just do this. Integers tell us or imply, remember the arrow, real number. So we know that to be fact. Integer tells us real number. All right? They're telling us that that's a fact. What's the next part say?
1/2 is a real number.
1/2 is real number. To use the law of detachment, remember the law of detachment says this implies this. This all by itself is true. Then what do I know about this?
It's all right.
All by itself it's true. But remember, it's got to go, look at how I'm doing it. Red marker implies pin. Red marker is true. So then pin is true. So on this one, this is like the first thing. Integers tell us real number. Well, what do we know about our number? It's a what?
Real number.
It's a real number. Is that where we need to start at? No, we needed to say 1/2 is a integer. And then we could have said that 1/2 would also be a real number. But since it went in the wrong order, can I say that? So, no conclusion. No conclusion can be drawn.
Oh.
All right, today is the 30th. Go ahead and start copying this down. We spent way more time than I wanted, so write very quickly because about 20 seconds from now I'm changing this slide.
How do you think the test?
Go retake it. Maybe if you're paying attention and everybody's nice to me, maybe I'll let you fix them, but I'm not doing retakes.
Are you recording your notes?
Yes. Right quickly, what we're going to cover today. Be able to identify special pairs of angles formed by intersecting lines and a transversal. And I'll explain to you what a transversal is. Hopefully you know already what intersecting lines are.
Oh,
Like you.
Shouldn't even put intersecting on there. Should make this. Coplanar lines So let's change that. You don't have to do anything to it if you don't want it. It's not a big deal. It's just bothering me because it's not really mathematically correct as far as the way I want to explain it. Change it in the second part though. I know none of you have gotten that far yet. Coplanar lines. What's it mean to be coplanar?
Two lines, anything that's in the same.
Same plane, all right? On the same plane. So change this to coplanar. 30th. I'll change my notes. I have to remember to do that. Bad thing is if somebody gets online and gets them, they won't be changed.
Read from my mind.
Huh?
Read from my mind.
Nah, that's a pain in the butt.
Hey,
Sounds like a lot of work.
It
Yeah,
is.
it sounds like too much work for one word. By coplanar. Oh, yeah, coplanar.
Because I wrote it twice. She does everything I do. All right, looking at these lines, just very, very quickly. Looking at these lines. If I pick the green line and this orange or tan line, whatever it is, tell me a transversal to that. Tell me a line that intersects both of them.
red.
The blue one. All right? Now, the red one also, what's different?
Looks like a
Red one intersects both of them at the same point. The blue one intersects them at two different points. This right here is what we need to have a transversal. This red one isn't considered a transversal because it intersects the 2 points at the same point. All right? What looks to be true about these two, the red and the blue? They look like they are parallel. Why am I giving Ethan the death look? Because he said they were what to each other? Congruent. Can lines ever be congruent to each other? No. What else can never be congruent to each other?
Plane.
Planes. What else? Rays, points, lines. And now, can angles be congruent? Yeah. All right, go ahead and copy this down. As you're copying this down, I'm going to rewrite this right here because I don't like the way it's written. Line AB, this is the symbol for parallel. Parallel to line CD, that's the way that's read. That symbol right there means parallel. Right, quickly. Make sure you draw this picture. These things right here, these are arrows, but they're not arrows like on the end of the line. They're arrows that show us that those two lines are parallel. So you have your two lines. This tells us that they're parallel. If you read it in a sentence, this symbol tells us that they're parallel. And this other line that intersects both of them at two different points is called a transversal. So you got your two coplanar lines. How do I know those two lines are coplanar to each other? They're on the same plane. They're both on the whiteboard. How you going to know that two lines in the book are coplanar to each other?
Wait,
They're on the same page.
what did you do down there?
Just drew this. I rewrote this right here because I didn't like the way it looked. Anytime you have two coplanar lines and a transversal, how many angles are going to be formed? 8. Every single time. Every time it's going to look something like that. There's going to be 8 angles there. All right? And those 8 angles are special things to each other. You already know some of them.
Vertical.
Give me a pair of vertical angles. 6 and 7 are vertical angles. We already know that. What do we know about 7 and 8? They're adjacent. What else? They're a linear pair. They're also what to each other? Supplementary. Is there a whole bunch of those in the picture? All right, so we know all that stuff. What we're going to learn today is some of the other things that these angles are related to each other, how they're related, or what they mean to each other.
Oh, 2 and 5.
That's what we're going to talk about here in just a minute.
They're special.
We're going to talk about stuff like 2 and 5, then we're going to talk about stuff like 2 and 7, We're gonna talk about stuff like 2 and 6, how they're related. We're gonna talk about like 1 and 8. 2 and 8 are nothing to each other. We don't have a special relationship with those.
1 and 6.
2 and 6 be vertical.
Not vertical.
So 3 and 6 have nothing.
3 and 6 have something to do with each other.
Because they're,
Now, when we get to it, I bet you could just about figure out what they're going to be named, because math people aren't very creative, so they name stuff by what it is.
So like, why would it?
You probably have learned this before. 2 and 8 just, they're not special, they're not in,
This is gonna be confusing.
This sounds
No,
so
it's not.
familiar, like, not even hearing the name, but talking about them, it sounds so familiar.
Alright, write these down. Before you write this down, I'm going to write something in this first one. Planes are named with 3 points. Well, this isn't quite right. I left a word out. Sorry, going to go right here. What word's going to go behind that 3 there? If I remember. Non-collinear. 3 non-collinear points. Why not 3 collinear points?
Because it don't make sense.
If I give you 3 points and they're all on the same line, is there only one plane that's going to contain that line? No, if I just put 3 points up here, there's the whiteboard, then there's some plane going in here, and I'll show you here in a minute
I've heard that.
when I draw it.
I've heard of that.
That's what we got last year, and now
Yeah, I think they both did.
Top vote.
No, Harrison and him.
Alright, so on this first one, start of the year we learned about planes. And when we named the plane, they gave you some fancy cursive letter in the corner and you named it plane P. Now what they're saying, instead of naming it that way, you can name it with, I don't know why my pen's messing up like that. You can name it with any 3 points that fall on the plane. I'll be out of the way in a second. So tell me one way we could name that plane.
ABE.
ABD would work. Give me another one. CBA. Give me another one. EDC. All those would be ways to name that plane. Now, when you name it, you got to write the word plane, ABD. I think that's the one I heard first. All right, there is no symbol for plane, so you got to write out the word. Now, why did I put non-collinear in here? If these 3 points right here, even though they don't look like it, if ED and C all laid on one line, is that the only plane that would contain that line? No, there's some other plane. Am I bothering you? There's some other plane that comes right through here. Would it contain that same line? So we wouldn't know which plane we're talking about.
Isn't that the same as like student
So they got to be non-collinear.
Isn't that like the same for like 2 collinear points then?
Right. But 3, it takes 3 to make up a plane, 2 to make a line. Parallel planes. What do you think parallel planes are?
Planes that are parallel. So, but like,
planes that
They
are
don't go
intersect.
into
Yeah.
each other.
Planes that don't intersect. Planes that don't intersect. No I there. Planes that don't intersect. I'm going to skip skew lines for a second because I want somebody to give me the wrong answer for parallel lines that I know you're going to give me here in a second.
2 lines that don't intersect.
Lines that don't
Is that right?
intersect. What's wrong with that?
Is it 2 lines?
Aren't they
Do
like
not.
a certain distance on the?
Yeah.
Be next to
Parallel lines that do not intersect.
or-
All right.
Just like each other.
Close. You need something in the front there.
2 lines that
There are
form the same
more lines?
plane that don't intersect.
Exactly. So, these are what kind of lines?
Perpendicular. Not perpendicular, sorry.
Intersecting, right? Intersecting lines. These are still intersecting lines, but they're special, they're perpendicular, right? These are what kind of lines to each other? Parallel. Now that's what your teachers in the past taught you because they didn't think you could understand all the spatial stuff. So now I'm going to tell you that everything else. Is that the only way that the lines could be related to each other? What's another way? How? Do you know how it is?
I don't know what he said. What did he say?
So we got intersecting lines and we got parallel lines. Tell me what else I can do with these lines. Like that?
Like,
Oh.
not touching each other.
What kind of lines are those?
Skew.
Those are skew lines.
Score.
Now, are they parallel to each other? No. The way we identify between parallel and skew lines is that parallel lines have to be on, somebody said it, the same plane. So, right out in front here, we're going to write coplanar lines that don't intersect. What's skew lines then? Non-coplanar lines that don't intersect. Which one do you think we're going to deal with more?
Skew line.
No. How are these lines related to each other? They're not, are they? They're skew lines. Can we do a whole lot with that? Nah.
So wait, would parallel lines have to like always be towards the exact direction?
Yep.
What's skew line?
Non-coplanar lines that don't intersect. Transversal. Transversal is a line that intersects two coplanar lines. Line that intersects two coplanar lines. So, don't help me out here, Skylar. You're such a kind young lady. I have my two parallel lines. Skylar's going to use her forearm to make a transversal for me. Hold your arm up here, and I'll help you out. Hold it straight up in there. Ta-da! What's her arm? Transversal, because does it intersect the two coplanar lines? Yeah, that's all a transversal is. Intersects, and actually, I'm sorry, that's wrong. Intersects the two coplanar lines. What should I finish out this with? At different points. Thank you. Good thing you guys are in here to keep me in line. At different points. Otherwise, I would have left the wrong definition up here.
Only even.
And then we would have failed.
Yep.
Can you read that out?
Yep. A line that intersects two coplanar lines at different points. At different points. All right, write this out. Each one of these numbers, listen carefully and write quickly because I'm going to go over it quickly. Each one of the numbers here should have an angle symbol in front of them. I didn't put them in there because I don't know how to get them on the computer. So they should have an angle symbol.
Exterior.
Yeah, exterior angles. Yeah, draw the picture. As you're writing it down, exterior angles. Where do you think exterior angles fall?
Inside.
Inside,
Outside.
outside.
Interior.
Yeah, I know.
So, exterior angles. Exterior angles. Out here. Exterior, exterior. Where do you think interior angles fall? They're the ones inside the parallel line. Interior angles. Yeah, they're working on something.
They're on this too. I see them.
No, they're not Amish, they're children Baptists.
Oh, they look on there.
Seems like living in this area.
I have an Amish dress.
Know that, don't you? That's nice. We get the difference. Yeah. Now, notice, as you write down the rest of these, math people, real creative. Guess why they call these consecutive interior angles?
They're consecutive and
Because they're consecutive angles on the interior. Guess why they call these alternate exterior angles?
Because they're
Alternate.
Because they alternate sides and they're on the exterior.
outside of it.
Exactly. So don't make this harder than it is.
Oh, wait.
This one here we use some. Not a whole lot, but a little bit. Alternate exterior angles, we use very little. These last two, might want to put some asterisks beside them. We use them a lot. Now, the only one that doesn't have a name that makes sense like the others do is the last one, which is corresponding angles. And we'll talk about that here in a minute because it actually does make sense. You just probably don't know why yet. The name. Consecutive interior angles. 3, 4, 5, and 6 are interior angles. Consecutive interior angles are ones that
I'm saying like.
on the same side of the transversal there. So they're on the same side. There's nothing in between them.
But there.
All right? Those are consecutive interior angles. Alternate exterior angles. These are exterior angles. These are exterior angles. Which ones do you think are on alternate sides?
Those two.
1 and what? 8. See how they're on opposite corners from each other? That's alternate exterior. Alternate interior. Watch carefully on alternate interior. I will get rid of it. Calm down. Alternate interior. These are very important. Angle 3. I'm going to trace it. And angle 6. Alternate interior angles. What's formed when I trace both those angles? A Z, or if it was turned the other way,
A lightning bolt.
might be a lightning bolt or an N. All right, so a Z or an N or a lightning bolt. Those are alternate interior angles. Corresponding angles. Watch what happens when I trace corresponding angles. Angle 5 corresponds to angle 1. What's formed then? An F. All right? Now, with corresponding angles, listen so you understand this. This will make this easy. To find corresponding angles, take the two lines, shove them together. Don't fold them or anything else. Just smash them together. Corresponding angles lay over top of each other. So angle 6 would lay over top of what? Angle 2. All right? Make sure you understand each of those. There's one missing up here. Which one are we missing? What other one could I make up a name for?
Corresponding.
Got consecutive interior, alternate exterior, alternate interior, consecutive exterior. We just don't use them. This book doesn't use them. I don't know why. All right, that's your assignment.
Can I try if I